A $110 planet killer? Let's take a look. Hello and welcome to the channel. I am your host, Carlos Padron. If you're new to astronomy, perhaps you've seen images from the Hubble Space Telescope and wondered what it looks like in real life. Well, what's inspired me is sharing the night sky through my telescope and having the community engage. Once you see the moons of Jupiter or the rings of Saturn, even the sharp, deep craters of the moon, you begin to connect with it in ways not possible with photography. As they say, nothing beats the real thing. Of all the telescopes I own, the segment that excites me the most are the ones geared at the entry-level spectrum. The reason being, for a modest amount of money, say $110, one can acquire an amazing bit of kit. The Sarblue Planet Mate is one such scope. For those just starting out, I'm glad this video intercepted you. Many don't know where to begin. It's rather odd in this hobby. For comparison, no one asks what shoe should I get or which car normally. So why are telescopes different? Do not buy a cheap department store telescope. Those are hobby killers. That is the number one thing unanimously all astronomers do believe. So here I will lay down some considerations for a beginner and tell you why, in my opinion, this scope fits the bill. As far as targets, what do you want to see? Planets, the moon. They're great for a beginner in terms of ease of acquisition. How about terrestrial, nature and wildlife? How about some nebulas and galaxies? Well, they're harder to find than planets generally and require larger scopes and in dark skies. How about doing a little bit of astrophotography? These are just some of the overall considerations you gotta look at when you try to buy your first telescope. For the beginner, I'd strongly emphasize a scope that can show you the planets, the moon, with not much fuss. This is very important. You would be surprised as to how often I meet those new to the hobby that struggle to identify the planets in the night sky. But I will say, with a simple smartphone app, this isn't really a big deal. You don't know where to look, just pull up your phone and load the app up and it'll show you where it is. Observing is a skill as well as an art. Also, the more light pollution, the worse seeing becomes for deep space objects like galaxies and nebulas. For planetary, light pollution really isn't affecting it, which is why I believe that's where we should begin. In terms of different designs for telescopes, there are really three major ones. The first one, and is probably the one most are familiar with, are the class of telescopes called a refractor. Refractors are what people generally think of a telescope. Next is a Newtonian or a mirrored reflecting telescope developed by Sir Isaac Newton. And the third class is a compound telescope, or catadioptrics as they're known. We'll get into each of those here in greater detail. Refractors are what people generally think of a telescope. It's a long skinny tube with a lens at the front and an eyepiece at the back. Mounted on a tripod, these can be great scopes, especially in the higher end ones like APOs or called apochromatics. Since they are grab and go, they have minimal cooldown and are maintenance free. However, in the entry-level segment, these are generally achromats and it may have one or two lenses and do exhibit some false color or color fringing, as it's known, on the edges of bright objects like the moon, Jupiter, and some other stars that are very bright up in the sky. This is called chromatic aberration. It's not good to look at, although if you're a beginner, this may be something you're not really even aware of. You're too busy trying to find the object and looking at it and taking the sky in. But once you have more observing under your belt, this becomes quite apparent. The next major class of telescopes are those called the Newtonian reflectors. These are color-free and are generally great value for money, especially for its aperture size. But they require constant collimation, which requires a laser or a Cheshire eyepiece. This is relating to the mirror alignment. It's not difficult to do if I was, say, next to you showing how it's done, but reading up about it or just watching video can still make this rather challenging. If one is willing to spend some time learning this step or has someone that can help them through this, this may be a great option. Some other downfalls are they tend to be large and bulky, especially over the 6-inch range of aperture. Portability becomes a concern if you want to take your telescope to a dark side, which I totally recommend. If you do get a large Newtonian, just be mindful that they may not fit in your car or will take some considerable work to get it in it. Some of these Newtonians are kitted with an equatorial mount, and that is not my first recommendation. They are rather challenging to set up, and they're not very fun. A tabletop mount or a Dobsonian mount are great for ease of use, and I generally recommend those over the equatorial mount options. And the last major group of telescopes are those that are the compound types, or catadioptrics as they're known. These take design elements from both refractors and reflectors, meaning it has both refractive optics lenses and reflective optics mirrors. The most common types of compound telescopes are those of the Schmidt-Cassegrain, or SCT for short, and Maskatov-Cassegrain telescopes, MAC for short. The pros of these designs are they fold the compact optical tube design, which makes them rather short, stubby scopes. They're more portable than Newtonians. They offer more magnification for a given aperture size, which is great for getting close-ups of small objects. These are really great for the moon and planets. Some of the cons, I would say, though, is that they cost more than Newtonians. The long focal length is an issue for deep space astrophotography. Generally speaking, the mounts need to be substantial to correct that, and short exposures are required as well. That's a bit more of an advanced topic. They require more collimation than a refractor, which has almost none, but they don't require as much fiddling than, say, a Newtonian, so that's good. Dew and cool down can be an issue. Dew is relating to water accumulating on the lens front after extended use during the night, and cool down refers to the amount of time required for the optics to equalize with the outside air. The shorter or the smaller the scope, the faster the cool down is. If you go for larger apertures, say the 8-inch or larger class, they do require probably 30 to 40 minutes to cool down, so keep that in mind. And I would say one of the last negatives of this design is that they do generally have the narrowest field of view. So if you want large, sweeping Milky Way galaxy panoramas, look elsewhere. So some of the specifics about the Tsar Blue scope. First, it's got a focal length of 750 milliliters, which is great. That's a good enough length to give you some good magnification power. The telescope design is a catadioptric or compound, specifically the Maskatov or MAC. The objective on here is 60 millimeters. The highest useful magnification is about 120x. The eyepiece supplied is a 20 millimeter focal length size, and that gives you about 38x power. The cell phone camera adapter also comes with it, and as well as the tripod. The piece that is used in conjunction with the eyepiece is called the prism, and it's in a diagonal 90 degrees, and it right sizes the image perfectly as you're looking through it. Some telescopes do revert the image and flip upside down. This one, however, is a very true field view. It is upright and left to right is perfectly centered, so there's no problems there for landscape or nature photography or viewing through the day. Now that we've walked through the different optical designs, let's look at why I believe this is the best recommendation for the complete beginner in the $110 range. First, it's small and very portable, has a great mirror design that can reveal itself by removing a cover on the top of the optical tube. It's great for demonstrating to little ones how this is used. It's super easy to use and requires no collimation or lining out of the box. This sample I have was awesome. There was no fidgeting at all needed. It was just literally point and shoot, and there I off looking at the moon. The star test was very good, showing great alignment. The mirror was figured very well. I can tell the optics on this thing is definitely of high quality. There was no chromatic aberration as you would expect from a mirror design. There were no false colors on the limb of the moon. In my sample, it didn't do over. I live in South Florida, so this may not be an issue where I'm at, but it could be wherever you're located.
That's easily fixed with a little neoprene cover or foam cover on the front end of the scope, just to get the air off of it. Um, and to how the views. So let's look at this. So the moon looks razor sharp. I've compared this with a friend's 127 millimeter reflector Newtonian, and the little 60 millimeter aperture Mac displayed richer and sharper views with lots of contrast of the moon. Basically, my little scope was more than twice as small and produced an image that was way better than a scope of that caliber. Gives you really just a true feel for how powerful this little thing is. The cell phone adapter is super easy to use. It allows you to take some astro shots of the moon, landscape, or nature pics, if wherever suits your fancy. Once someone takes a pic of the moon, I will say they would inevitably be addicted to this hobby, so watch out. As far as the planets go, so I did have a look at Jupiter. The banding is visible, although not a large image with a 20 millimeter eyepiece applied. I had to use my other 5.5 millimeter eyepiece I had lying around to give me the best views. If you have other eyepieces like I do with a 10 millimeter or lower, the views improve dramatically because of the image scale is much better. Of course, that's if the scene conditions allow. Right now, Jupiter and Saturn are visible in the early morning before the sunrise. Note Jupiter and Saturn are near their best views in July, not right now, when observing them improves dramatically near opposition. Saturn rings are stunning and easy to make out. The Cassini division, I couldn't make it out yet, although I suspect I could see them near July when opposition is at its peak. Mars is still up in the sky right now, but it looks like a reddish star due to the Earth moving further and further away from it since our previous opposition that we had back in October. The next Mars close approach is December 8th, 2022, so be on the lookout for that. So, the things I didn't necessarily like about this scope. Well, viewing the moon at zenith, or when it's right above your head, was a little tricky to observe with this included tripod. Also, the sight for aligning the scope to the target, the little peep sight, can best be described as iron sights if you're familiar with that. And it could be a little tricky to learn in the dark, so best practice that with landmarks or bird watching during the day to hone in your skill. Since the telescope can open up, revealing its inner workings, which is really cool, I strongly recommend either JB welding this or gluing it shut if this is to be for a little one scope, so they don't touch the inner workings of it or mess up the mirrors. If fingerprints get on the mirrors, then the performance will be greatly affected, and cleaning it is something that should not be attempted unless done by a skilled astronomer. I've cleaned mirrors before in telescopes. Depending on the design, it could be rather difficult, and it is very nerve-wracking. The focuser can take a lot of turns to get a picture into focus, so I will say be patient. For those just starting out, there isn't a perfect telescope. If there was, we would all have it. However, with a modest budget of $110 gets you a fine beginner telescope that will show you the moon and some planets in the night sky. If what you're after is what a good small Mac telescope provides, which is rich, sharp, contrasty views of the moon and planets, with portability in mind and ease of use, well, this is the one. I strongly recommend that there isn't a stronger balance of performance per dollar than the Sarblue Planet Mate 60. Its ease of use performance hits well beyond its price range. This will help you get acclimated to the night sky and be lots of fun for daytime observing and also for nighttime celestial objects. Thanks for stopping by, and if you found this helpful, please leave a comment. Give it a like, click on the subscribe button, and get notified when other review vids come along. And clear skies.